17 over 1 or just 17. Okay, perfect. We just need this last one to be the same. So far, this is definitely looking like a direct variation. Let's do this last one, 68 divided by 4. 68 divided by 4 equals, okay. Oh, does 4 go into 68? Oh, let me see here. So 68 divided by 4. 4 goes into 6 one time. 1 times 4 is 4. 6 take away 4 is 2. Drop the 8. 4 goes into 28 17 times. So yes, 4 goes into 4 one time, and 4 goes into 68 17 times. That is awesome. That means we have a direct variation. It has the same constant of variation each time, which is our k. So we know that k equals 17. So yes, this is a direct variation. Because of that, we can write it in the form y equals kx, where k is equal to 17. So we just plug that number in for k, and we get y equals 17x. That is our equation. Awesome. So yes, this is a direct variation. We showed our work, and there we go. Perfect. Okay, let's move on to the other one. All right, so now what we're going to look at is the money market. So this was the CD. So now we're going to figure out if there's a constant variation from the interest from the money market over time. So we're looking at K equals not Y1, but Y2 over X. And what that means, that is Y2 represents the interest from money market over time. Perfect. Okay, let's go ahead and get started. So our first one is going to be 19 over 1. That is our y over our x. So 19 over 1, which is just 19. Awesome. Then we're going to do the next one, which is 37 over 2. 37 over 2. And 37 divided by 2 actually ends up being 18.5. Now those are not the same. What that means is this is not a direct variation. And that's pretty much it. So once you find one of those K values that are not the same, you know that this data, when you're comparing the interest from a money market to time, it does not represent a direct variation, and you're done. Okay, however, if you are getting the same constant of variation each time, you need to keep going. And if you get 17 each time, or any number, the same number every single time, then that does represent a direct variation, and then you need to go ahead and write the equation. So it is now your turn to do a problem. So our lovely friend, the pause dragon, is coming to help us out, and he's flying from far, far, far away. And he's reminding you to pause your electronic device, work this problem out, and then come back in a little bit and check to see if you got it right. All right, see you later. Good luck. All right, we are back, and we are going to go for this one. It says Mr. Ortega has $2,000 in a CD and $2,000 in a money market. So here we go again. We have a CD and we have a money market. Awesome. We know what those are. The amount of interest he has earned since the beginning of the year is organized in the following table. Determine whether there is a direct variation, so that's what we need to do. Determine if there is a direct variation. between either of the data sets and time? If so, find the equation of the direct variation. Okay, we can do it. All right, so if we see right here, we have the interest from the CD versus the time. Right here, that's where that data is. Oh man, I made it the wrong color. Oh shoot. Well, this is what we'll do. We'll make it orange. We'll make this orange, so it'll all be orange. And we'll make this orange. You know, this orange right here. So this is orange now. The CD is orange. Does it look orange? I don't know. You're going to have to go with it. So the interest from the CD is here, and then the interest from the money market is here. It kind of looks orange. That's going to have to work. Okay. When life gives you lemons, you make some orange lemonade. All right. Okay, so here we go. Interest from the CD is here versus time. Interest from the money market is here versus time. So we have two different tables again. We need to go ahead and analyze the data and see if there is a relationship here. So let's look at the first one. We're going to find K. This is our X, and this is our Y1, and this is going to be our Y2. So we're going to find our K, which is going to be our Y1 over our X. The Y1, that is representing the interest from the CD over time. All right, and that's what we're going for first. So we're just going to start Y1 over X, 12 over 1. 12 over 1 is 12. Awesome. Okay. Then we're going to go 13 over 2. Did I say 13? I meant 30 over 2. I'm sorry. 30 over 2. 30 divided by 2 is 15. Whoa, these are not the same. So what does that mean? It means this is not a direct variation. Not a direct variation. Okay. Whoops. Got it. Okay, so not a direct variation. Let's go on to the next one. What do we have over here? We have, okay, we're going to find the K, the constant of variation. It needs to be the same relationship between all these data values. K represents Y2 over X, and the Y2 is really representing the interest from the money market over time. Okay, so let's look at the relationship between these numbers and see if it's a direct variation. So we're going to look at the first one, Y2 over 1, which our K is going to equal 15 over 1, which is equal to 15. Okay, cool. Let's look at the next one, 40 over 2. So our K is going to be 40 over 2, and 40 divided by 2 is 20. So these are not equal, not the same. So this is not a direct variation. That's kind of a bummer. I was looking forward to a direct variation, but these are both not direct variations. So anyways, hopefully you got the right answer. If you did, yokinekimashita. We will see you next time. All right, goodbye. Oh, can you see that? Wait, hold on, let me see. I'm just looking at my screen. This is not a direct variation. Okay, we'll try that again. Okay, if you